I'm going to help you out a little bit with the assignment 18 to 30 evens and 44 to 47. We're working on solving rational equations and inequalities, and I've picked a few of the more challenging ones to show you. So the first one I want to show you how to do is 26. We're subtracting two fractions. They equal 1, and we got to figure out what q is. So we're going to multiply by the common denominator, basically multiply by each of these denominators so that we can cancel them out. So everything gets multiplied by q plus 3 times 2q minus 3. If we multiply everything by the same thing, we're not really changing the value of q or the equation. Okay, this is hard to squeeze in, but there we go. Okay, so once you do this, you're going to be able to eliminate each fraction and cancel out those denominators. So q plus 3 cancels out in the first fraction, and I have a 2q times, in parentheses, 2q minus 3. Then we're subtracting. In the second fraction, I'm canceling out 2q minus 3. So I have a 2q times, in parentheses, q plus 3. And then it equals 1 times these factors. Basically, I need to multiply or FOIL these two binomials together on the right side. Okay, so now let's do all of our simplifying, all of our multiplication here. We're going to distribute, and we get 4q squared minus 6q minus 2q squared minus 6q. Then over here we're going to use FOIL. Q times 2q is 2q squared. Q times negative 3 is minus 3q. 3 times 2q is positive 6q, and then 3 times negative 3 is minus 9. Okay, so now that everything's multiplied out, let's combine like terms. 4q squared minus 2q squared is 2q squared. Negative 6q and negative 6q is minus 12q. Equals, on this side I can just put the q's together, so I've got 2q squared plus 3q minus 9. Now we're ready to solve. Now, notice the 2q squareds on each side cancel each other out, because if we subtract 2q squared from each side, you're left with nothing. So I'm going to subtract 3q to get the q's together. And I have negative 15q equals negative 9. Now let's divide each side by negative 15, and we'll reduce our fraction. So q equals a positive answer here because you're dividing two negatives, and if I cut these each by 3, I get positive 3/5. Let's do 28 as well. So I've got three fractions here, and I need to come up with the lowest common denominator. So between 3, 6, and 4, all of those numbers go into 12. The lowest common multiple is 12, and I'm also going to have to multiply by a y so that I can cancel out the y. So if I multiply everything by 12y, you're going to see the denominators cancel out. Remember, you can't multiply by different things in different fractions, so everything has to be multiplied by the same thing, and you're going to pick something that will cancel out with each denominator. So the y's cancel out in this first fraction. 3 goes into 12 4 times, so I'm taking 2 times 4, and that's 8. Plus, in the second fraction, 6y goes into 12y twice, so I'm taking 5 times 2, and that's 10. Then we have the greater than sign. 4 goes into 12 3 times. I still have the y there. 3 times 3y is 9y. And I guess before I started, I should have said that y cannot be 0 because I'm solving an inequality. Okay? Now, we don't really care about this symbol right now, so I'll just make it equals. I have 18 equals 9y, so that means y is 2. Actually, that's one of the points on my number line. Y doesn't actually equal 2 because our symbol is greater than, but let's make our number line with the two values now, 0 and 2. And we need to test some points. So I'm going to test -1, +1, and 3. And we'll see which interval here gives us our solution. Are the solutions less than 0? Are they in between 0 and 2? Or are they greater than 2? Let's see. So I'm testing -1 right now. So I'm going to take 2 over 3 times -1 plus 5 over 6 times -1 and see if I get an answer bigger than 3/4. Now, one thing I'm noticing right away is that these two fractions will be negative, and if I'm adding two negative fractions, there's no way that they're going to be greater than 3/4. So my answer here is no. -1 is not a solution, and that means everything to the left of 0 is not a solution. Let's test +1. So I have 2 over 3 times 1 plus 5 over 6 times 1. Is that greater than 3/4? Well, it's 2/3 plus 5/6. 5/6 is already bigger than 3/4, so my answer is yes. So that means 1 is a solution, and actually everything in between 0 and 2 is a solution. I'm going to use open dots because I'm strictly greater than these values. I don't want to include 0 and 2. Let's test 3 now for our last point. So I'm taking 2 over 3 times 3 plus 5 over 6 times 3, and I'm going to see if I get a number bigger than 3/4. Well, 2 9s is 0.2 repeating, and then I have 5 18ths, which is going to be a pretty small number. Is that greater than 3/4 or 0.75? The answer is no, it's not, and so 3 also doesn't work. Anything to the right of 2 doesn't work. So here's your solutions. Finally, you want to write your answer using your variable. Our solutions are between 0 and 2, so we want to say 0 is less than y, y is less than 2. Here's how you write it. Next, number 30. This is one of the word problems I included. The band has 30 more members than the school choral. If each group has 10 more members, the ratio of their membership would be 3:2. How many members are in each group? When you solve a problem like this, you really only want to use one variable. So let's say that B equals the number of people in band. How would we represent the number of kids in choir? Well, there's 30 more members in band, so B minus 30 gives you the number of kids in choir. Now, if each group had 10 more members, the ratio of their membership would be 3:2. So if I say the band kids plus 10 more over the choir kids plus 10 more, that would give me B minus 20 instead of B minus 30. It should equal the ratio 3:2. Now let's eliminate our fractions. I'm going to multiply each one by 2 over B minus 20. And I'm going to let you finish this problem. How could you solve this for B? And then you need to say how many members are in band and how many members are in choir. Okay, last one that I'm going to help you set up is 47. We have an inverse variation problem, just a review from, I think it's from 8-4. So y varies inversely as x. Y equals 24 when x equals 9. Find y when x equals 6. If you want to label these, you have y1 and x1. y2 is the missing value, and we know that x2 is 6. Now, here's the proportion for an inverse variation, just to remind you. We're going to go x1 over y2 and set it equal to x2 over y1. They're opposite here. So plugging in these values, I know that x1 is 9, y2 we're missing, and x2 is 6 over y1 is 24. Now we're going to cross multiply and then divide by 6. So 9 times 24 is 216. 216 should equal 6 times y. Divide by 6, and we get y equals 36. You can see that each fraction is equal. 9/36 is the same as 6/24, so they both equal 1/4. Okay, good luck on the rest of the assignment.